Not me talking the entire time on mute. Sorry about that. Hi, my name is Isabel. You can call me Isa. I'm a coach for Major League Hacking. Thank you for joining me for another Global Hack Week. Today we will be doing data science. The registrations for the session are still not open, according to Kai. So I think what you're referring to is the check-in, right? Because my link says events instead of organized. So I think I have to, yeah. Okay, so I'm going to bring it up with Mary to give us a better check-in link. And then ideally she'll have it fixed before the end of the session so that you can get checked in. Okay, so I have now sent Mary a message about the registration. She should have that. She might be able to fix that before the end of the session. So y'all will be good there. I'll check again in like a few minutes to see if she got us a new link. Is everyone cool with that? Sorry about that, friends. Anywho, I got a little frazzled for a second there. My name is Isa. I'm a coach here at Major League Hacking. I use she, her pronouns. A fun fact about me is I have seen a lot of anime, and for this and all other links that I have, there's a little icon so you can go to wherever I'm going, basically. What are we going to do today? So we are going over the basics of data science. I have a track with 3 parts, and I am breaking it down into 1 and 2. For today is going to be the data science lifecycle and exploratory data analysis. So this is like super duper basic. We aren't doing any machine learning, any AI, or any like that. This is very, very intro level. And then tomorrow we will be implementing a model from start to finish, again, based on what we've already learned today. But I think you can, like, if you already know what I'm going to talk about today, you can skip this one and come tomorrow. It should be like standalone. You can work with what I'm talking about then. And then finally, on Friday, we are going to be talking about clustering algorithms. I want to take a moment to thank my professor. I am repurposing what she taught me to teach y'all. So my classwork is kind of what we will be going over. But yeah, so we are so for the folks who are having trouble with the registration link, I have already informed Mary that our link is a little botched. We will get that fixed by the end of the session, ideally. But it's not something I can fix myself. I have to wait for them to fix it. Sorry, friends. Awesome. So the way that this is going to work, and then for those who are not familiar with the streams that I've already had, all of my stuff is on a link tree, right? So the slides, what I am working through is in here. I'm going to put that in the chat. That's my link tree. It includes, link tree. It includes all of my slides, including the past ones, but the one that you care about right now is the data science intro track. Awesome. So going over the life cycle, just so you get a sense of, I'm gonna put it in the banner that the check-in link is being fixed as we speak. Okay. No, that's too big. Oops. Okay, I'm going to leave that there for anyone else that's going to ask about the check-in link. Awesome. So the data science lifecycle, there is a link to a pretty solid like textbook style resource if you're interested in learning more about data science as like a science as a career choice, etc. This is a pretty good resource. I've linked it there. And the 4 kinds of questions we usually ask in data science include descriptive, exploratory, inferential, and predictive. So descriptive is like, can you describe how trees are in New York City? Exploratory would be which boroughs have more trees. If inferential would be, I'm inferring that if Manhattan has Central Park, then Manhattan must have the most trees. Is that true? Predictive would be, in the future, which borough would have the most trees. So in all of those examples, I'm talking about trees in New York City, but the way that I'm asking about them is what's changed. Awesome. Sham has confirmed that the link is fixed. I will paste the link again just so folks can access it. Boing. Awesome. And then I can get rid of that banner. There. So this is the link for the check-in, and then this is the link for the resource. If you go on the link, like, you can follow anything that I'm showing you from this one link, because my slides are there, the links are in the slides, the instructions are in the slides. So anything that you're asking for, Maruti, and anyone else that's asking, is going to be in this link tree, like anything I could ever talk about. Awesome. So I'm going to leave that up there until someone has a comment that I want to show, emphasize, but for now, that's staying there. Thank you. I appreciate you. So the question we are solving today is there a neighborhood in New York City with more trees than people? This is an example of an exploratory question where we're looking at what about these neighborhoods, or like what is in these neighborhoods that would, what am I trying to ask? But basically, it is the question that we're asking today. And then I have a data set for y'all. So the first link and the second link are our data sets. These are what we will be working with during today's session. The first link is the tree data, like just the trees, nothing else. And then the NTA map on the second link is excuse me, let me clarify what NTA means. It was like neighborhood tabulation areas. That's what NTA means. I'm going to put that there just like in case anyone asks. NTA stands for neighborhood tabulation area. It's basically like a very small neighborhood. I think they're separating it by zip code, so that'll make it a little easy for us. So yeah, this is the geographic data. This is the tree data. And then the last link is what we will be using to, in order to like actually do the coding, in order for us to not have to like do any of setup of the environment, like making sure that everyone has Python installed, an IDE that everyone understands. Just to make that easy and streamlined, we are using Google Colab. So Google Colab is like Jupyter Notebook. Thank you for joining at 12:40 in the morning. I appreciate your dedication. That is more than I can say for myself. But another thing is that Google Colab, I kind of edited it a little bit so we can have cats on while we're coding. Boop, boop, boop. Awesome. So Google Colab will make it so that we don't have to worry about any setup. And I put here, so if you scroll through, because I won't be able to show two things at the same time, I have all of the instructions in these 3 slides. So I have separated them by function so that we can check each function if it works. So like the modularity, the splitting up per function means we can check per function, per like, okay, we are cleaning the data. Does this work? Can you make the data frame? Does this work? Can you count the areas? Does this work? We can separate them, and then we can debug a lot easier versus having all of it in one function, you know? So if someone is asking for the link for the slides, everything is in the link tree. The first link that says data science intro track, that is the slides for this workshop. Awesome. So we are starting with cleaning the data frame, and then there are columns that we need to rename and to drop in order to what's the word I'm looking for? Streamline, to clean the data. Yeah, so we're cleaning it. Depending on what year it is, because we have 3 years. So here we've got the portal. Okay, so if we're going into the New York City Parks link, so the trees count link, the first one, we're going to scroll down into this part where we shall see, no, not that one. I think it's the report link. Yeah, but that's images. Give me a second. I'm looking for just the data. Ah, there we go. So if we scroll down to analyzing the data, we got 1996, 2006, and 2016. The year is a little off. 95, 1005, and 15. So all of these are what we're working with. And then the NTA map is the fourth one that we're working with. So those are our 4 data sets. So in this activity, in this workshop, in this project, we will be cleaning all 3 data sets so that they're like, even though they're a different year, you can access the same, let's say, tree count regardless of what data set it's from. So that's the goal of why we're cleaning these data sets. And then making the columns the same name in the NTA map and the tree census will make it so that if I call, let's say, where am I? If I call the latitude and the longitude, it'll be the same for the trees and for our neighborhoods. Does that make sense to folks? Oh, by the way, if you have any questions, if you need something clarified, if I said something that doesn't make sense, I am checking in the chat. I have a separate screen just for that. So I am here if you have any questions. Cool. So we're starting with cleaning the data set, and then our next step is going to be making the data set for the neighborhood. So this first one is the trees. The second one is the neighborhoods. Count by area just returns how many trees per neighborhood. And then our fourth function is what, like the details of the tree. So this is an extension of that third function, the details about the trees and then the neighborhood. And then the final one, which is where our statistics are going to come in, compute summary stats should be able to give the mean and the median, but we're going to do this without NumPy just so we don't get spoiled by all these libraries. We are going to solve this without using NumPy, so just base Python library. Cool. With that being said, what I'm going to do, so I have here df and then my parameters, and then what this is saying, let's keep that here. So I'm starting with def and then that function name. So that's how you define a function in Python. I am making like vague assumptions that some people who are joining this workshop have like some experience with Python, like just the syntax, just know the syntax. But if you have specific questions about, like, for example, this is specifying a default. Like if you don't say what year it is automatically 2015. If you have questions about stuff like that, feel free to put them in the chat. Awesome. So we've got our data frame and then our year. And what we're going to do here is the function does the following. So my hi Polarvoid, hi Evo Skull, blow up the font. Got you. I think this should be solid. Cool. So in the, I think I can do it like this. It'll be smaller, but I think it'll still fit. Can you hide? No. I think I can go presenter view and then hide this. There we go. So we got our code on the right and we got our instructions on the left, and we're going to make our instructions a little bit smaller just so it's not taking up everything. So we say that if the specified year is 2015, so if year is equal to 2015, then this function should take df and drop all the columns except those. So in order to do that, we say df is equal to df, and then these square brackets will, nope, that's not what I was trying to do. I can copy and paste from there. Let's do that. Sorry. But my square brackets will make it so that only those columns will show up. So let's see if this, let's see. I'm trying to make it like wrap so I don't have to scroll rightwards. It's not letting me. That's not today's problem, so we're just going to leave it alone. So if that's my year, then my data frame, whatever df is that I will be returning later, will be a subset which includes only these columns. Now, if year is equal to 2005, also if I'm working too slow because the instructions are there, you're more than welcome to like skip ahead. If year is equal to 2005, then my df would have a subset called these guys. I know you can't see that far in, but if you have the slides from the link that I had, you shouldn't have a problem. But just in case, gosh, I'm trying to zoom it in. There. So, and rename the corresponding columns that differ from 2015 to the 2015 names. Now, in order to do that, actually, give me 1 second. There is a lag, friends. There is definitely a lag. Okay. Okay. I think we're okay. That was a lag. We can say df. I'm trying to see if it's, yeah. So here we are replacing the function in line. So we don't have to say this new thing is renamed. So we say df dot rename. So calling the function rename into, so we say columns, curly braces, and then whatever we're renaming. So I think we were saying status colon becomes health. SBC, NTA, latitude. Nah, people can't read. Latitude and then longitude. So that's the only thing that's changed in this column, or I mean in this data set. And then we're going to 1995 if year, you want to be clean about it, if year is equal to 1995, and we are returning df is equal to df, and then these golly gee. So in order for me to copy paste, I have to, oops. Okay. I'm copying these columns. And now I'm going back to presenter view. So here we have a few things that are different. Excuse me, friends. We've got df.rename columns. So static diameter is turning into tree dbh. And then condition is going to be health. And then SPC Latin stays, SPC Common stays, and then we're changing NTA 2010 into just NTA. And then latitude and longitude stay. Awesome. So those are our 3 conditions for the clean DF. And then we just say return DF once we're done. Regardless of the specified year, the function should return the resulting data frame. That should be good. And then what we're going to do is say clean DF. And then let's say we're doing the 1995 one because that's the one where we're changing the most, right? We're going to say not export, API. Yup. So we're going to stick to CSV, copy. Oh, I'm bonkers. I skipped a step. Wait. So that's my data set, but I forgot to read the data frame. So df is equal to, no, yeah, I should. Df.read CSV and then df. Because it'll take this link and turn it into a data frame. But data frame is a pandas thing, which means I need to say import pandas. So in order to use this function, I need to import this library, which is the only library we're using. We're not going to use NumPy for that last one. And then this, if I run it, if I press play right here on the left, I should be able to get a data frame that has only these columns. So let's try that. Allocating, connecting, initializing. Boop, boop. Okay, so I have an error here. String has no attribute. What am I doing wrong? That's probably syntactical. Give me a second. Read CSV. Ah, because it's not DF, it's PD. And then we say import pandas as PD. There we go. This should be good. Let's try that again. All right. Okay, so let me zoom out. This is now our data frame where we got, no. I was supposed to start in 1995. But this is not, that's all of them. So my cutting of the columns did not work. Is it like this? Let me try. No. See, PD.drop makes you drop the specific like column. It doesn't. If what you're listing is slice data frame, I think is what I'm looking for. Slice. Okay, so read CSV should be good. Creating a data frame should be good. Slicing. iLock is what it's giving me, but I don't think that's what I need. Give me 1 second, friends. Yeah, it's two of the brackets, but maybe I don't need this. Let me try that again. Nope, But nope. If year is equal to 1995, yeah, might not even be. All of them are staying. I'm debugging. I'm debugging. I'm goofing. If anyone is catching my error, let me zoom in. If anyone is catching my error, see, it's supposed to be 2 brackets. And then what? What am I doing wrong? What are you complaining about? I'm just trying stuff out now, friends. No, it wouldn't work either. It's not cutting off all of them. This. Oh, oops. It's still giving me everything. So I'm not cropping this right. I'm not cutting my columns correctly. So I don't think I need an else, but if that's what it's bugging about, I'm gonna remove my else. Yeah, so I have taken the suggestion of removing the elifs and saying df is equal to blah. Oh, ooh, what'd I do? Oh, it worked. Okay, so I have to change those then. So what had to happen was I name it something different after I read it, and then that gets cut twice, so 2 curly braces to remove the columns, and then I renamed the columns, and I only got these. This was my goal, friends. This was my goal. But it still says NTA 2010, so my renaming didn't work. I don't think this should be here either. So my next debugging problem is line 12. My columns are not renaming. It should not. Maybe I also need to say D. No. Let's try this. NTA latitude, longitude. That is exactly what I wanted. Okay. So all of them need to have the equal, what's the word? The equal sign. You have an NTA in line 1. Yeah, not anymore. So we're good there. So the reason why it was complaining is because if I just leave it like this, just df rename, it'll print out the data frame. But what I'm trying to do is change the object itself. Therefore, so someone is suggesting df.columns. I could do that, but since I had a different set of columns for each, like for each condition, I listed them out instead of making like a single one. But We've solved that issue. We have cleaned our data frame. So that's one. And then let's say, let's comment that out and say a different clean df for the 2005. Again, I'm going to say API, I'm going to say CSV, and I'm copying the link. And then I'm going to put that here and say 2005. I still have health, I still have tree DBH, and I got all my 7 columns. So we're all good on our first function. Where it is. So clean df we have solved. Now we're going into make NTA df, which is our NTA map. In order to do that, I'm going to make a new box, a new like plaything, add code. That way, when I run the first function, I don't have to run anything else. Like I don't have to run the others. So that's our testing. I'm putting one here for the next function. That should be fine. So now we're going to say def, and then we're going to paste, what was it? Make NTA df, and its file name. For this function, what we have to do is take in that name of the CSV from the demographics, which is more views, no, export. That's download. What if I just want the link? About? Permalink. And I think you just say .csv at the end. Wait. 1 second, friends. Let's try this. So permalink is what I'm copying. Gosh. I'm going to close that. Don't need that anymore. And I should be able to say df ed read csv. No, gosh. File name. And then what I'm testing it with is, oops, make NTA df with this. So I'm checking it incrementally now since I made the mistake of just doing everything all at once in the first one and getting stuck. So now I have a parse error .csv. Forgot that. Let's try that again. Got an error there. 1 second. You've gone. Ah, I found the link. It was complaining because the data that I was receiving was not the right format. So let's try this instead. I'm still going to have the CSV at the end. Nope, not it. More views, filter, visualize, export. API endpoint, there we go. Try this again. But it's saying .json. So I think this thing is just JSON. So I'm going to say from JSON is just read JSON. Let's try this again. Okay. So we've got that one, right? So we've got our make NTA df running. However, it was asking us to replace the column names. So we're going to do that again here. And now we know to say df equals df dot rename. And then we're going to say columns and then our curly brace. And we start as NTA code, but we want it to just be NTA to match. Oh, wait. The function should open the file name as data frame, returns a data frame containing only the columns containing the NTA code, the neighborhood name, and the 2010 population. So I think what it's asking for is NTA code, NTA name, and population. Let's try that, and let's try that. It's complaining. None of them are in the column. Geographic area borough. Zooming out. This is what I need. Total population 2010. So it's not that those are the names of the columns. It is that I will change them into that. So df is equal to df. And then one of the ones that I need is total population in 2010. Labeled as population. We've got NTA code right here. Very long name. See why we need to clean our data. So we've got that NTA code, NTA name. Awesome. So those are our 3 columns for this data frame. And then we're removing that line. We're zooming it back in so everyone can see. And we're going to say df rename. And now we're going to say columns is equal to the curly thing, where this NTA code, oopsies, see, there, oopsies. So we're going to copy this. That turns into NTA code. And then we're going to say this, which is going to say NTA, nope, not capitalized, NTA name. And then finally, this is just going to say population. So we've got that. We're going to run it and then run this driver code. And now we only have 3. There are 2 underscores in my NTA name. Okay. So now we only have the 3 columns that we need, but just for, I don't like that there's a 0.0 there. Remove trailing decimal in Python. Dot normalize. Population. Yep. So EF population. So only editing that column. EF No. Copying this. Round decimals is equal to 0. As type. I'm Googling it and it's telling me to add as type. I'm going to listen to instructions. Let's see. Let's try this now. And it still has my 0.0. I don't want to manually change it. I could regex it in order to clean it. If we know that that's how it's going to look, I think I can do that. Mm-hmm. Let me try this, friends. Do numeric. No. Do underscore numeric. Syntax error. Let's try this. Not what I'm looking for. I'm going to leave it alone. I'm going to leave it alone. I was just trying to get rid of this. And it's not letting me. But I tried to do this. That can be homework for y'all. If someone can tell me in the chat how I'm getting rid of the 0.0. I think it's complaining because I have the not nulls, or not numbers. NAN stands for not a number, to those who are unfamiliar. But I got my data set, NTA data frame to work, so I'm going to call it a win. So our next function is going to be count by area. So let's go make a new code, def count by area. And then that is putting in just the data frame. And it wants us to return a data frame that only has NTA and Num Trees. Okay, someone is saying DF population. Do I have to? I probably have to. I'm going to copy this. And then as type int. Let's try it. Let's try it. Let's try it. Oh, commented it out. Cannot convert. Okay, so you had the right idea, Abikash. However, it has NA values. So you have to you have to only apply this to those that are numbers without removing those not null values. Okay. Just up the difficulty for y'all. So this can only be applied if it's already an integer. If it's not null, if it's null, if it's not a number, then ignore those columns or ignore those rows. So someone is suggesting this next. So let's try that. DF population is equal to int DF population. Let's try this. Okay. See you, Eva. Thanks for dropping by. Okay, now we got a type error that the series as a whole cannot be converted to an integer because I think what this is doing in Maruthi's example is the entire series, the entire column is being turned into a singular integer instead of applying this integer into every item of population. So I see what it's doing wrong, but I haven't figured out how to fix it yet. So again, still leaving it to y'all to find the correct conversion of that while I go into count by area. And count by area was asking for NTA and Num Trees. I think it's just because we already learned how to get the column. NTA Num Trees. Right? That's all I need. I think that's all I need. I am wrong because num trees is the sum of the number of trees grouped by NTA, which means I need to use the grouping function. I need to use the grouping function. I'll be right back, friends. I'm not feeling very well. Give me a second. Sorry about that, friends. Needed to make a bathroom break real quick. Hope you got some drinks. Hope you got a little break for that. Where was I? Let's go back into it. We finished our first function, which was clean df. We finished our second function, which was make NTA df. We are now on our third function, which is count by area. And we had determined that it wants num trees to be a function, to be a column created by the NTA groups. So group we need a group by. Oops. There you go. This is not at all what I was trying to do. Num trees. Let me try this first. df group by, and we need to group by NTA. What does that give me? Oh, I have to say return. And we're going to comment this out and say count by area. And we are returning a data frame that returns the NTA column. So we're gonna, the trees might have it, yeah. So I'm gonna say df is equal to that, and they say count by area is df. We already confirmed that df works, so count by area did not return anything. Oh, because I didn't run it. Whoops. It's returning an object. So what happens if I print it? I did not do that right. It always needs to go that way. And let's try that again. I'm going to Google this to debug accordingly. Nope, not there. There. There we go. However, that is not what I was referring to. Was it? Num trees. Give me 1 second, friends. This is P3, I think. So let me clarify this. Count by area. So we get the data frame, and then we count, clean df. Our first function will go in here, and we say clean that. And then we say df is equal to group by. That's what I found earlier that I forgot how to use. And then we say group by the NTA, which is what we have here, group by NTA. And then we say by the sum, because num trees is the sum. And then what we're going to do then is reset the index. So we got that, where we're changing that into num trees. Name is equal to num trees, which is what it was asking us earlier, where our second column is num trees. And then we're going to set that all into one frame, one data frame, and then return it. That should be enough. Let's try this again. So this is not what I need. And then count by area. We wanted this length. Where's our 2015? Because that was our default, and we haven't tried that one yet. So we'll say CSV, copy, and then count by area. Oh, current quotation marks. And then we're going to run this, and we're going to run this. Nope, there's two. Oh, typo. Count by area. Awesome. What are you complaining about, friend? This worked last time I used it. Why are you complaining? Requested does not match index name. What happens if I don't do this? Data frame has no to frame. Let's ignore you then. I have latitude and longitude. Because I don't need them. I need tree DBH to be whatever it is, whatever num trees is. So I'm going to say df. We said rename earlier, and we need it to be column. Tree DBH turns into num trees. Cool. And then we're going to say df is just NTA and Num Trees. That should be good. Let's try this again. No, I was wrong. NTA is not an index. NTA is not an index. How's everyone doing? Sorry. Let's try this. There we go. Just the NTA and just the num trees. I think that'll change it into this bold into from that bold into a regular data frame. It's not letting me though. Data frame has no attribute to frame. So we're just going to leave that as it is. Okay. We got NTA and num trees. We're good. Count by area is a go. Now we have neighborhood trees. So now what we've had a lot of experience in is data cleaning, which is a very tedious part of data science. It takes up most of your time and is not very glamorous. But I'm glad we got through that. And now we're going to try joining. So a neighborhood tree, NTA code, and NTA name. Make NTA DF should be able to do that. Oh yeah, we never solved that. NTA code, NTA name, and population. NTDF also has population, so we're going to ignore that part. Tree DF is the left table, so what we're going to need for this one is def neighborhood trees, where we get a tree DF and an NTA DF. So we've got two data frames and we're putting them together. And what this is saying is the left table is TreeDF. That is what we are basing it on. Like all the NTAs are going to be based on TreeDF. And then whatever NTA has that tree doesn't is going to be ignored. The main source of like the information is TreeDF. That's why it's on the left. So we're going to say left join right here. I mean, where is my code? So we've got NTA DF. Because right now we have NTA DF currently has NTA code and NTA name. But our tree data, if we go back to 1995, not you. Let's comment this out. So what we have on CleanDF is we have NTA, just NTA. So what we need to do for make NTA DF, or like our NTA DF, we have to change NTA code to just NTA. So that was another cleaning thing that we have to do. So we have NTA DF rename, gosh tabs. NTA DF rename. And then we've got columns are going to be NTA code becomes just NTA. This is important because once you're joining it, the column that it has to find in common should have a common title, like a common column name. So if it doesn't have that same name, it won't know what to connect it to, what to connect the information with. Join tables pandas. This is, I'm trying to show an image. Yeah. So this is what we're trying to do. We're getting the same column on one of them, and then we're putting the things they don't have in common together into one table. So I'm going to copy this image and put it into our slides so that folks can understand this a little easier. So I'm going to add a duplicate and then get rid of this and then put this in there. Just the middle. Whatever. Okay. So now you have that information on how we're doing the inner join, left join, sorry. Awesome. So with that being said, I'm going into neighborhood trees. That's right. So we've got neighborhood trees. We've renamed it, and we're ending with return df. And that df is going to be pandas.merge. We're putting the tree df and the NTA df that we just changed. And we're saying how left join on what? Sorry. On NTA. Shouldn't be NTA code, it should be NTA. And now let's try that first. Let's get that there first. Neighborhood trees is gonna get, what is my tree df? This is 1995. No, df 95, right? And then my tree df is df 95, while my NTA df, so NTA df is that one. So let's try it now. DF95 is not default. Typo. So now it has all of those columns put together, right? See? Oh, let's show it all. So now I have NTA name, NTA, tree DBH, all of those table, like all of those columns put together. Now what I need next is, once I have that merged, let me clean that so that it's only NTA, it's only Num Trees. Did I fix Num Trees earlier? Yes, I did. We're including NTA name, and we're including population. And then let's run this again. And it's giving me an error because Num Trees is not in index because of NTADF. Because this one was bugging out. Right? I haven't been running everything. Num Trees is not in index because the way that I did Num Trees earlier wasn't accepted. But let me try this anyway. Count by area is complaining. No, it's not. It's that. Let me fix NTADF, why don't I? Try that again. Oops. There we go. And then let's try this again. Nope, we don't got it. Are in columns. None of index blah are in columns. Because the rename is right here. Let's try that again. Num trees is not again an index. But that's kind of what I need to answer the question of which one has trees. So I have to fix it. Let's fix this. Let's fix this. Count by area is what's complaining. Let me find another place to have this answered. We got this, friends. Someone is suggesting DF num trees. The num trees isn't okay. It's saying num trees isn't even there to begin with. Like from this version. One second, friends. All right, friends, I'm going to need to pause for another quick second. Take a break, drink some water, take a stretch. I will be right back. Alrighty, friends, let's get back to it. We were stuck on changing our tree DBH to num trees when we're counting by area. When we did the group by, I think, okay, so let's try and debug this again. We're going to ignore this, this, and this. We're only using count by area. This is exactly why we separated our functions, so we know which one's bugging out. So here we have NTA, we have num trees, right? But we do have warning the value of blah. The default value is deprecated. In a future version, will default to false. I think what we can do is remove all the null values first. I don't think we did that in our very first function. So let's try and do that. We never did it, yeah. So let's try. We've got tree DBH group by NTA. Maybe with the cleaning, we'll remove all of our null values. It didn't say that before, but I think it's what we're gonna need to do in order to get this to work. So let's try that. Now we're gonna do that by just, okay, let's zoom in for everyone. And then say df.drop NA. We'll run that and then run count by area, because count by area uses clean df, and then we'll run our driver code, and we still have NTA, we still have num trees, we still have that error that says the value is deprecated. So let's try printing the df from, because you know how when we printed, let's say, this data frame, right? On the very left, we saw the index. But here, when we do the grouping, NTA became our index. So I don't like that. I think that's what's saying, that's what's complaining. So let's try and fix that. There we go. So what we're missing is as index false in our group by function. So NTA is our first, and then we're going to say as index is false. So let's try that and then run this. Dot reset index maybe. Now I'm getting rid of my NTA code by doing that. So that's not something I can do either. Alrighty, friends. Let's try. What else can we try? We can't reset the index because that gets rid of our NTA code entirely. So let's remove reset index. And we're going to run it again. And we've got NTA right here. But we need a new index. So let's see what we can do. Both give the expected result. That's not my expected result. I'm looking for not having the index group by not as index. By none, x is 0, level none. Sort, add group keys, squeeze. I think I got it, friends. I might have gotten it. So let's I'm trying to do reset index, but that's not exactly what we're trying to do. So we've got df by group by right here. So if we run just those two, what do I get? So I only need NTA. What else do I need? Let's go back to the instructions. NTA and Num Trees. And Num Trees is made out of the number of trees, which is tree dbh. Which is right here. Okay. Let's try that. And then running that. Because it needs two square brackets. Keep missing that one. So we still have the same two columns, but I think that's a series. No, wrong one. I think this is a series that we can then convert into a so it's a data frame. We're supposed to get in a group by a different kind of object. It's complaining. I think what we can do about this, friends, is since we have the second session tomorrow, I will come back with the right answer for this one and add it to that session, since we will be going over implementing a model anyway. Yeah, I think that might be the call that I'll make. Cool. So we have partially cleaned data during this session. We shall continue that in tomorrow's session, and then we'll complete the model and the clustering algorithms then as well. Awesome. I will call. Oh, can you say what the goal is again? Oh, so the goal is to see if there's a neighborhood in New York City that has more trees than people. What we are specifically trying to do here in clean count by area. Count by area is the function that we're stuck on right now. And count by area right here is asking us, is asking us to make a data frame that has just the neighborhood and the number of trees per neighborhood, which is kind of pivotal to how we have to answer our main question. But I'm kind of stuck there right now. So since I don't have the answer with me, I will bring it back during the next session, since we already went through the lecture of data science lifecycle today anyway. So that is what I shall do. I shall thank you for stopping by. Once again, the resources that I have gone through and will continue to go through are in the link tree. But yeah, awesome. Thank you, friends. I shall see you tomorrow.